Welcome back, everybody. Today we will be moving on to lesson 1.5, segments and their measures. Let's get it going. So we're going to be measuring segments and adding segment lengths together today. All right, there's some vocab. Please write this down. Here's your vocab. All right, so the very first one, it says the real number that corresponds to a point is the coordinate of the point. And that coordinate can be on a number line, it can be on a graph, on a grid. It just depends on what we're talking about. Today we're going to be talking about number lines. So a coordinate is going to be the exact point and the real number that corresponds to that point. All right, the distance between 2 points is the, make sure you know this, absolute value of the difference of the coordinates. Take the two coordinates, take the absolute values of those, and subtract. Okay? Next, the length of a segment is the distance between the endpoints. We're going to be finding lengths of segments. We're going to be finding distance between 2 points. We're going to have a lot of fun. The last one, okay, is going to be, it says in geometry that have the segments that have the same length are called congruent segments. Make sure we're writing this down. Congruent segments. And that word right there, congruent, is you are going to see a lot of. It means the same length. Okay, we're going to be talking about congruent segments today. We're going to be talking about congruent angles later, congruent triangles, congruent pentagons, a lot of congruency that will be happening in geometry this year. All right, let's do a couple of problems. Woohoo! All right, this first one you do not have to write down. Just watch me as I do it and pick up on it. All right, so it says find each length. The very first one, it says line segment BC. So I'm looking at point B, point C, and that distance. I'm finding the length of BC. Okay, remember, thinking back to our vocabulary, it says find the difference of the absolute value, or absolute value difference. So our absolute value of 1 and our absolute value of 3, we're finding the difference in between the two of them. 1 minus 3, remember when we subtract, we are adding its opposite. So our answer is going to be the absolute value of -2. Remember, when we're talking about absolute value, we are talking about the distance between 0 and that number. So the distance between 0 and 2, our answer is 2. So the length of BC is 2. All right, looking at AC. A here, C here, finding the length of A and C, or between A and C. We are going to look at point A is -2, not -1. What am I talking about here? It is going to be -2. Our point C is again at 3. We are finding the difference between them in the absolute value. Okay, so we take -2. Remember, when we subtract, add its opposite. -2 plus -3. Our answer is going to be the absolute value of -5. Our length is 5. Look at all that beautiful work that you get to show. Awesome. Let's get to a couple that you get to write down now. All right, so it says find each length. Take a moment, pause now, give them a shot. All right, looking at x, y, we first locate x, we second locate y. Now we're going to find the length of x, y. Okay, remember, we're finding the difference of the absolute value. Absolute value of 1.5 minus absolute 5. Okay, 1.5 minus 5, we are going to add its opposite. When you look at that, you will get the absolute value of 3.5, -3.5, because that 5 is negative. But we know that we are finding the distance between 0 and -3.5, and our answer is 3.5. And you can just leave it just like that. Next one, x and z. X is at 1.5. Z is at -3. We are going to find the distance between 1.5 and -3. So between x and z. Absolute value of 1.5, which is your x, minus -3, end of absolute value. When we subtract, add its opposite, we look at that and we take the absolute value of 4.5, because 1.5 plus 3, again, add its opposite to get plus 3, we get absolute value of 4.5. How far is that away from 0? 4.5. So the length of xz is 4.5. Because it doesn't give us an exact distance or measurement of distance, so feet, mile, meter, we do not have to have a label on these. Okay, so don't worry about a label. All right, please write this down. Here's another postulate. It says, if B is between A and C, then AB plus BC is equal to AC. All right, you might want to pause now because I'm moving on. All right, so it says G is between F and H. FG is equal to 6 and FH is equal to 11. Find GH. The very first thing I want you to get into the habit of is drawing your diagram, okay? Because then you can literally see what we are measuring, okay? We have a segment, line segment, that looks like this, where we have F and H. Okay, we know that G is in between F and H. We don't know exactly where, but we know that G is in between. All right, we know that the segment FG is 6. We know that line segment FH, which is this entire distance, is 11. Okay, we are finding GH, which is, I'm just going to put a little X there. Okay. According to that postulate, according to that previous postulate, we know that if we add up these two smaller sections, we will get the entire distance. Okay, so we're going to set it up as a formula. We are going to get 6 plus x, and we are going to solve, and we know that all of it equals 11. Because if we add FG plus GH, I'll write that off to the side here, we will get FH. The two smaller sections add up to get the bigger section. Get the entire length. Two smaller segments add up to get the long segment. All right? And when we do this, we're going to subtract 6 on each side. Okay? We know that 11 minus 6 is 5. So GH is equal to 5. Okay? Set it up as an equation and solve. All right, moving on. This is the last one. Let's give this one a shot. Pause now, try to answer it, and we'll see if you came up with the correct answer. All right, so I hope you came up and set up an equation for this. That's what I wanted you to do. We'll see if you came up with it. Now, 3x minus 1 is DE, EF is 13, the entire length is 6x. If we go back to that postulate, we know that DE plus EF is equal to DF. Those smaller two segments, small section plus small section equals the entire section, or entire segment. So DE is 3x minus 1. We need to add 13 to that to get 6x. All right? Very first thing I am going to do is I am going to bring my variables together. I want to get my variables together. I want to get numbers together. Variables with variables, numbers with numbers. So I'm going to get rid of this 3x. It is a positive 3x. We need to move it over to the other side of the equal sign, which means I need to do the opposite operation. It's positive. We're going to subtract from each side, which means I then have, and I'm going to scoot this up here, I now have negative 1 plus 13 is equal to 3x. I combine my 6x and my 3x. Okay, I need to subtract between them. Then I combine negative 1 and 13. When I combine those two numbers together, negative 1 plus 13, my answer is 12. Still solving for my 3x, or sorry, for my x. I need to get rid of the 3 next to the x. What operation is happening between 3 and x? It is multiplication. I need to take the opposite operation, which is division. Divide by 3. That cancels out my 3 because 3 divided by 3 is 1. So on my right side, I still have x, and it is equal to 4. Okay, 12 divided by 3 is 4. Now, remember, because we're not talking about labels, because it is not a word problem, there is no label here behind the 13, no label behind the 1. We do not need a label for x. X is equal to 4, so my answer is 4. I hope you got that. I hope you understood this PowerPoint. Let me know tomorrow if you do not understand it, because I will answer all your questions. Have a good day.